Hello everyone, my name is Wesley Davis and I'm with Team 4 in the SER401 capstone. Our project is the SolarSense wireless soil sensor project, and I'm going to begin by going over our Sprint 2 goal. Sprint 2 was our most recently completed sprint, and the goal for that was to control the data gathering process, report results via the web sensor, and store said results in persistent storage for use in the soil analysis algorithm. So the way I'm going to break down this video is I'm going to go over how we control the data gathering process, how we report it from the web server, and how we store the results in persistent storage. So to do that, first I just have to change my current network connection. Um, when you look up here, I'm currently connected to my local internet, but to access our SolarSense um, information and data, I just have to connect to the SolarSense network connection. And just to verify that I'm connected, it'll say SolarSense with a little check mark. I'm going to come back over here into Google Chrome and go to the home page for our SolarSense project, which per the sponsor, they want it at 11.11.11.11. Just hit enter, and it'll load up this fun little homepage. We're still working on the UI for it, but in the meantime, we have the two buttons. We have collect and scanning for sensors. The collection process is going to fulfill that first part of the task of controlling the data gathering process. So when I click that, it is currently making a connection to the Mongo database on the Raspberry Pi. And once it makes that connection, it'll display any and all data that is residing on that MongoDB collection. So this example actually fulfills both the first two, that we control the data gathering process by clicking a button, and it'll report that results from the web server onto the home page or onto a page. And again, this is still a work in progress. Um, this task falls under user story 1 in sprint 2, or not user story 1, I'm sorry, user story 11 in sprint 2, where we want the farmer to push a button to run the program to get the soil data from the server, from the database and display it. And yes, so that's it for that part. Now looking into the portion of the goal where we talk about storing the results in persistent storage. For the soil analysis algorithm, I'm going to reconnect to my local network right here, so that way I can SSH into the Raspberry Pi itself. Give that just a second. While it's doing that, I'm going to 3. There we go. Connect. All right. So once again, we're using MongoDB to store a lot of these. If I do show DBs, you'll see a SolarSense reports, and that's where we're currently storing the data for our solar sensors. So if I use SolarSense reports, and I show the collections that we have, the reports are being stored in this reports collection. So the DB reports.find, and I will include it for more of them. So currently, in the background, we have the Raspberry Pi constantly scanning for the sensors and pulling the data and storing in here. The way you can tell is right here off of the timestamp. This is from today's date. I'm not too sure why the time's a little skewed, because that'd be further, that's about 8 o'clock, and this recording's around 2. But it is pulling in today's current date and is storing that into our reports database, which then once again fulfills the third part, stores the results in persistent storage for use in the soil analysis algorithm. And that is it for our Sprint 2 or Artifact 2 review. Thank you very much and have a great afternoon.